Hello students, Mrs. Schmaltz here. This video is all about the number of solutions that you might have with compound inequalities. Before we get into the number of solutions, we need to remember that any equality joined by the word OR must be true for only one inequality. So basically when you graph it, wherever one inequality lies, or the other, all of those are your solutions. So if you get something like this, I'm not putting numbers in, I'm just doing a basic graph. Okay, or maybe it could be equal to. This has two inequalities as a solution, and so your answer might be x is less than 1 or x is greater than or equal to 3. So when it's an OR inequality, you would have these two joined by OR because all numbers over here and all numbers over here are true for one of the inequalities. Moving on to infinitely many solutions. You might have this. We might have x is greater than -2. And we'll make this 5. X is less than or equal to 5. Well, if the number to be a solution only has to be a part of one inequality, I have this continuing in this direction forever, and I have this continuing in this direction forever. So every number is over here or over here. So this is when it would be all real numbers, or all values of x, or infinitely many solutions, when you have arrows going in the opposite direction and it's an OR inequality. Finally, in OR inequalities, you may have only one inequality as a solution. An example would be this. X is less than or equal to 2. And over here, let's say this is 10, and x is less than 10. If your solution is everything that is under one of the inequalities, this inequality here is going to totally cover up that other inequality. So this inequality does not matter for our solution. The only thing that would matter is x is less than 10. Because everything in this pink inequality here has already kind of been run over by this other inequality, so it doesn't matter in our answer. And that is all of the special solutions or solution types for OR inequalities. Let's move on to AND. AND inequalities are a little bit different because the solution has to be true for both inequalities. So anytime that you would have two inequalities as a solution, it would be something like this when they are facing each other. The solution would be what's in pink here. Kind of looks like a barbell to me. Okay, it stops when you get to the other. Because even though this inequality goes forever this way, and this inequality goes forever this way, it's where they're both true, so it's where they overlap, which is right here. So this is where you could write a sandwich inequality of 2 less than x less than 5. The key to making the sandwich inequality is starting with your small value, putting a less than or less than equal to 2 sign, your variable, another less than sign, and your variable. And you always want it to go from small to large. Okay, let's look at the next type of solution. And inequalities with no solution. Remember that and inequalities have to overlap. It has to work for both. So if you've got something like this, there is no number that is here and here at the same time. That is impossible. So any and inequality that has arrows going in the opposite direction with no overlap is no solution. Let's look at our next type, infinitely many solutions. Inequalities only go in one direction. So if I had an arrow going here and perhaps one going in this direction, the overlap would be between them. So that is not infinitely many solutions. So let's try a different situation. Maybe I've got this going in the same direction. Well, I still only have an overlap then from here on. So that is not infinitely many solutions. Since inequalities only go in one direction, it is impossible to have an and inequality with infinitely many solutions. So this last type of solution for and inequalities, one inequality for a solution. If you have these going in the same direction, so x greater than or equal to 5, looks like this, and x greater than, let's say, 15. Remember, and is where they overlap, and this comes all the way over here, and you can see that it starts to overlap once we get to 15. And so every number that is true for both inequalities is going to be these numbers over here. So essentially, this is the only inequality that would be our solution. Since 15 itself is not a solution for this, we have to leave it as x greater than and not greater than or equal to. So this should be all the different special types of solutions for compound inequalities. Hope this makes more sense.